Please welcome Ted Schmitt, Jake Wall, and Matthew McCown.
Are these working? Yes. So listen, my name's Greg Zachary. I'm here very excited to introduce to you three leaders in the emerging field of conservation technology. I myself have great affection for sub-Saharan Africa. I have visited many times since 2000. And talking with Ted, Jake, and Matthew, who are going to join us in a moment, has been very, very interesting to me because they're working on a really exciting set of problems of bringing digital technology to the challenge of conservation and preserving wildlife. We're going to cover a lot of ground, so we're going to kick right off with Ted.
Thank you, Greg. Okay, my name's Ted Schmitt. I'm with Vulcan Technology. I don't know if all of you folks here in Portland know Vulcan is Paul Allen's company. And at Vulcan, with Paul's leadership, we're tackling super hard problems to try and make the world a better place. In fact, there's a whole team at Vulcan, myself included, that do nothing, Vulcan Technology, that do nothing but focus specifically on wildlife protection, ocean health, climate change, and other areas of interest for Paul in philanthropy. We get to work with our colleagues in aerospace, philanthropy, and really across all of the resources that he brings to bear on problems, as well as with great colleagues that I'm sharing the stage with and many others. I wanted to kick off by providing some context. A big project that we're currently doing is the Great Elephant Census. We're well into it. We're flying 20 countries in Africa to count how many elephants are left. And I think this will provide some context on the crisis at hand, as well as how technology and information can help address that crisis. So let me see if this will work.
Across Africa, we are losing elephants every 15 minutes, 96 elephants a day, and a year between 25 and 30,000 elephants. If we cannot save the world's largest land mammal, the prognosis for wildlife conservation is bleak.
The elephants are under the greatest pressure they've probably ever been.
This elephant was shot on Tuesday.
It's an incomprehensible amount.
It hurts to see that animal being killed just because you want a pair of tusks. And for what you want the tusks, I can't even explain.
Where are the elephants, guys? I don't know.
We know how fast we're losing elephants, but how many elephants currently exist? Our primary goal is essentially to count Africa's elephants.
The whole idea of a new Pan-African Elephant Survey is desperately needed. We're in the middle of a crisis, and the big question now is what's going to happen to the elephants.
There's so many unknowns, and this survey will provide us with some of the most important information ever to conserving the long-term survival of elephants.
Information is power. If you have the information, you can move mountains.
Thank you. So we are in the middle of a crisis. A lot of people don't even know that. We've lost roughly 20% of the elephants in the last 3 to 5 years. They're being killed at a rate of 30,000 a year right now. Sharks, which is another area, sharks and mantas we work in. You can look at this, really all wildlife is in steep decline across the globe. And it's what a lot of scientists are now calling the Anthropocene, the age of humans, basically, and the profound impact we're having on our environment. So we're looking for ways to leverage technology to change that trajectory. Some of the threats, the ivory being used for ornaments. In the middle there is shark fin soup. It's actually a wedding soup, and the shark's fins are cut off. You can see here thousands and thousands of shark fins. The sharks themselves are allowed to drown in the ocean, so It's really pretty devastating stuff. So what can technology do? After all, we're here to talk about technology. There's a lot of things that we can do. Certainly measure and count and understand what's happening out there, but also protect the rangers that are out there on the front lines, to protect them, expose trafficking through data, make those connections, find out where the trafficking networks are, stopping wildlife commerce, improving land use. As human populations grow, there's less and less land for wildlife. We can at the very least figure out how best to use that land so that we have the least impact on wildlife. And finally, really data-driven policy and wildlife trafficking and how do we control that. Huge challenges. You might say, well, gee, we have cell phones in our pockets, we have these smartphones, we have all this miniaturized technology. Some of the things we face as conservation technologists are really hard engineering problems, actually. And this is just a thing showing how we did the counting. This is a picture from the Great Elephant Census that's emerging. The red areas are places where there's the most devastation. This is the kind of information you can start to build when you can gather the information and present it and make an impact to change the trajectory. We did not use image recognition technology in this. We used humans staring out the window, obviously, and we did that because of the crisis. We didn't want to wait for technology innovations, but at the same time, we are innovating and looking to use things like image recognition to be able to scale the identification and counting of animals in the future. And we need help doing that. We're also trying to count sharks. And let's see. I'm going to skip this because we're short on time. It's a great video about the sharks. We're using camera traps to census sharks and mantas. And then we're engaging directly with the folks on the front line, trying to help them solve the big problems that they have. And I'm just going to show this. This is something that we're building that brings all this sensor data together. Matthew and I were talking about it's kind of boring. People think it's boring to bring data together. It's actually, for us, the most exciting thing. When you have camera traps, you have metal detectors, you have GPS tracking, elephants tracked, and you're able to bring all of that data together and use it in an impactful way to change conservation. So I think with that, I'm going to hand it on to Matthew.
My name is Matthew, and Matthew McCown. I'm the CEO, co-founder of a startup called Conservation Metrics. And I think Ted really set the stage well about the space we're operating in. And I think it's a good time right now to sort of take stock on where it is that we stand on developing a sustainable planet. And in the late 90s, the United Nations came up with 8 or 9 Millennium Development Goals, they were called. Simple goals for us as a human societies to try to achieve to develop a sustainable planet. And if you look at how we're doing 20 years on, the good news is on the left side of the slide. In the last 20 years, about 1 billion people have been raised out of extreme poverty. Millions of children who would not have survived to the age of 5 are now alive and they're in school. And I'll add that 90% of kids are in school around the planet, and there's almost parity between girls and boys in school. Human health. We've made huge inroads on devastating diseases like AIDS, HIV/AIDS, tuberculosis, malaria, and others. Now, if you look at our side of the sustainability goals, the picture is not so rosy, as Ted alluded to. We continue to lose forest cover at an alarming rate, especially in tropical Africa, tropical South America, tropical Asia. We all know that carbon dioxide, nitrogen pollutants, phosphorus are being released at increasing rates. 1/3 of the global fish stocks are overfished. And we keep having this extinction crisis. A much larger proportion an ever-increasing proportion of animal species are in danger of extinction. So what can we learn in the environmental side? What can we learn from the successes in the development side? And I think the main thing that I've taken away from this is a relentless pursuit of data-driven decisions on the development side. Groups like the Poverty Action Lab at MIT, the World Bank, have trialed a number of different potential solutions to, let's say, getting girls in school. And they'll do randomized control trials in all the schools in Tanzania. They'll try out different techniques, and then after a few years, they'll assess the data, and they'll go with the one that has the best return on their investment. Their dirty secret about conservation, even though it comes from science, from scientists, I'm a biologist, we don't have those same metrics. We don't understand how much better eradicating invasive species is to creating new, new breeding colonies for this species, let's say. We just don't have those data. The primary reason for that is that animals, plants and animals, are hard to count. Can you see the frog? You know, a lot of them don't want to be seen. Who could see the nighthawk? Down there on the lower right. And those that don't really care whether you're watching them or not present huge logistical challenges. And namely, that is we have to send teams of people out to remote locations. It's expensive, logistically challenging, it's invasive and detrimental sometimes to these sensitive systems. And we can't possibly scale it. So we four of us started Conservation Metrics to provide affordable, scalable measurements of conservation outcomes and population trajectories. We are leveraging an ever-increasing number of electronic sensors in the world. You know, the Internet of Things also can move into the wild spaces. We currently are using cameras and microphones, but there are a number of other sensors and sensor platforms with which you can census large areas of the world. The problem that Conservation Metrics is solving is actually what do you do with all this data when you get it? Huge terabytes and terabytes of data streams from remote corners of the world, and we apply deep neural networks to detect patterns of interest and quantify either numbers of animals, diversity of species, et cetera. And we also apply sophisticated analytics to the data streams to provide the information that's needed to make data-driven decisions in conservation. Some of the things we're doing right now, we're helping the Great Barrier Reef Marine Park track seabird populations in the face of global climate change, doing a number of before and after projects so we can compare how effective different conservation investments are. And we're doing some impact assessment and mitigation assessment, in this case, birds flying into power lines, and we are a very, very rare event. We're able to document that rare event because we can scale, and we can also document how effective mitigation actions are. With that, I will hand the mic over to Jake.
Hi, so I'm Jake Wall. I work with Save the Elephants, mainly in Kenya. And today I'm going to talk about a female elephant called Kulin. So Kulin is a Swedish word which means strong wind. So this is Kulin. She's in Kenya. And she was born in 1987, making her 29. She was ID'd in 1997, so we have a long-term project in northern Kenya where we're IDing based on the ear patterns. So we know most of the individual elephants in Samburu Reserve. So she's had 3 calves, 2001 male, 2006 male, and a 2012 female. She's part of the Winds family, so she was Harmattan's daughter, and she was first collared in 2010. So what we do is we attach a big tracking collar, which has a GPS and a satellite connection, and it transmits a fix to our server about once every hour, so we can keep tabs on what the elephants are doing. She was featured in the BBC series, The Secret Life of Elephants, if you ever get a chance to watch it. Exactly a month ago, she was shot and killed. And this is just one of hundreds of thousands that have been killed in the past 5 years and over time. But Cooling in particular is a female that we know. So we have a speed algorithm which monitors her movement. And this is this series of text messages we started getting. So this is what first alerted us to her condition. And here she is. So we went up to follow up on the ground, and she had been shot 4 times, once through the mouth, once through the trunk, and twice in the leg. And we think the 2 bullets in her leg are what led to her demise. So she died. So reconstructing her movements over the last sort of 2 weeks. So we think that she was shot March 10th at 2 a.m. Because immediately after that, she streaked to the water. So at the top of the screen is the Loyjuk Swamp. So elephants will typically do this when they're wounded. Their instinct is to get to water. So she was with her family as well at this point. She only spent about an hour at the water before heading south. And we think she was trying to get back to Samburu Reserve, which is a relatively safe haven. So at this time of the year, the conditions were incredibly hot and dry. There was lots of cattle. Nomadic herdsmen were using the Loyjuk Swamp to water their cows. Northern Kenya is a bit like the Wild West. Everyone's got an AK-47, so there's lots of potential danger there. So we think she was running from Loyjuk trying to get back to Samburu. So at around 3:12 p.m. on March 10th, she stopped and she started heading north again. We think this is where her and her family split ways, because the rest of her family showed up in Samburu, her calf included. And so we started getting the immobility or low speed algorithm alerts at 3:54 a.m. on March 11th. And she spent about 3 days in that area, so every orange dot is a new algorithm point alert. And then she returned to the Loyjuk Swamp, and that's where she spent the next 10 days. So we intervened with the vet, and we tried to treat her, but we think her leg was probably broken by the bullet, so there's really nothing we could do. And at March 27th, 2:47 a.m., that was her last position. So we're at a tech conference. So we are using technology to the best of our ability. We have callers, they're reporting in real time. But I would love if all of you could think about how could technology have maybe prevented this, and how could we have used technology to, possibly to intervene more quickly. So if we had, for instance, a gunshot sensor in that collar, maybe we would have been able to measure the gunshots as they happened and been alerted. So no one was ever caught for this. There was no, there was nothing we could do. But maybe had we known immediately that there were gunshots in the vicinity, we could have sent a patrol team the next morning. Similarly, if we'd had drones that were operating, maybe we could have run drones over the area and figured out where people were moving and where the cattle were, the cattle herds. We think this was done by cattle herders, but we're not sure. It could have also been poachers. And then also, if we'd had a heart rate sensor and been able to measure the health of Cooling, would we have known earlier what was happening to her? I mean, everyone's got a smartwatch these days that's able to record a temperature and a heart rate, but we don't have that yet on these collars. And so there's a number of things that we might have been able to use technology for to help prevent. And also, we could have used better remote sensing. So if we had an algorithm that could pick up on people from satellite imagery and known exactly where the settlements were by recognizing when and where Cooling was she close to human settlements? Should we be worried about where she is? So these are all ways that we're trying to experiment with and think about technology as applied to this very vast, very dangerous ecosystem where there are reserves, but they're very small in comparison to the overall range of the elephants. The benefit for us with elephants is that elephants are huge and they can carry a lot of payload. This collar on this bull elephant weighs about 20 pounds. So we're able to use elephants in a sense as a test bed for testing technology. We don't have to necessarily miniaturize it right away. But ultimately the goal would be to be able to track elephants without having to put this big cumbersome collar onto them. And we also have to think about how technology might be able to interface. I mean, the real core of the problem that we're seeing with elephants is the interface between humans and elephants and the coexistence. And so how do we use technology to engage local peoples, who most of them have cell phones nowadays, but that wasn't traditionally the case. So it's this huge area. It's very, but I think technology can play a role in this and engaging people.
This is a very sad story. Reminds us of how humans are capable of great things and also terrible things, even at the same time. Do we want to take some questions now?
Yeah, absolutely. So
And see, this is a very great combination of high-level knowledge and on the ground, and I wonder if it's evoking any responses from people in the audience. Yeah, right over there.
Yeah, so my question is, in my line of work, I work with a lot of data to try and explain it to people to care. When I see this, it's devastating, but we know climate change is potentially destroy the planet. So how do you make the data digestible to break through the barriers that we have?
And let me just restate, so how do we make the data useful? What kind of sensor storytelling, what kind of narrative comes out of this? Very important question.
I'm gonna start with that. So that's a great question because there are different audiences for this data, and I think conservation biologists they focus on the science, which is tremendously important. But I think what you're asking is, how do we reach an audience beyond that and really use this data and make it come to life to tell a story? In fact, for the Great Elephant Census, we're in the midst of doing exactly that. And we've engaged some folks with basically data artists. It sounds like maybe you might consider yourself a data artist. And really telling a story with the data. There are some great examples out there, but only a few. I think we're leading up to, there's a big thing called the CITES, convening of the parties, where huge decisions are made about wildlife trade by 180 countries. And leading up to that in September, we're looking to take the Great Elephant Census data, which is an enormous amount of data about elephants and actually any animal large enough to count from 300 feet in the air, and really tell a story to help inform policy, but also to reach folks. So incredibly important thing to do, and we really need skills, folks who know how to do that. It's a different kind of skill. So,
can we get another question? Yes, young lady.
You spoke a little bit about the shark fin soup and also about the ivory trade, and a little bit about community outreach. But how are you using technology to educate? It seems like that market still exists for ivory and shark fins. So how are you guys using technology to kind of eliminate that need?
Matthew and Jake, you want to take a crack at this?
Well, actually, we aren't in right now, wildlife trade. So I'll pass it on to Jake. But it's a super question, and it starts to get down to this same question, actually, of how do you present this in a compelling way that's not so depressing that you just switch people off right away. And Jake and I were just talking back in the green room. I never thought I'd say that, but we were talking backstage about, the need. We have really rich data sets. They're amazing data sets, and finding the different ways that we can engage, our different audiences can engage with that. I'm working with a lot of government folks, foundation folks, so they're actually looking for, they can interpret the data. But the general public, I think we need some PR and some data artists.
Jake, do you have a thought?
Yeah, how do we get our elephants on Twitter? And that seems to be the challenge.
Literally? We might get them on Twitter?
We would love to get our elephants on Twitter.
That could improve the quality of Twitter, though, too, so that's another plus.
They've already been on Street View, so.
Yeah, we do have them on Street View. So we're trying to use ways of getting the message out, social media. In fact, one of the biggest funders for elephants in the last year has been the internet sales of elephant T-shirts, which is, you know, another venue we would never have thought of. You know, we're applying for scientific funding and stuff, and really it's like internet T-shirts could be the answer for conservation. So,
Wow. Let's try to get gentlemen.
Back there and started early.
Oh, okay.
It's interesting, the elephant trade has been something we've looked a lot at work. We do a lot in anti-terrorism, and the poaching trade is financing a lot of terrorist organizations in the area. And curious, like, have you guys considered sharing, I mean, I know you talked about kind of some of these summits, but sharing some of your data with, I guess, international communities that are this is not just kind of a capitalistic problem, but does finance terrorist organizations. So, I guess who you guys might be sharing that data with that could prevent that.
Good question. Is there a way to work with law enforcement within the regions or globally?
So sharing information about traffickers, wildlife traffickers, is definitely an area of focus for us. It's a lot about building trust. You want to know who you're sharing with, and there are a lot of not so great folks that are, that seem to be in a place of authority, and you have to be really careful about that. So that is a human problem as much as a technology one, but actually where technology can really come to bear there is providing that trusted environment, assuring folks that are sharing that information that the data and the information is only shared in a way that won't end up doing more harm than good. So it's an interesting technical challenge as well as a human challenge.
Let's try one. I have another question over there. This is going very good.
Well, to follow up on that a little bit, and one hears about sort of geotagged pictures from safaris, for example, being used already by poachers to help sort of locate where animals are. And so, is this? You describe this as a sort of as a technically challenging problem. I mean, the question is it actually solvable?
So
is it
through
possible?
technology, is it solvable?
Right. I mean, is it possible to design a system that makes this kind of data available to any group other than a relatively small circle without putting them in? Putting the animals themselves.
Matthew, is it possible to design a safeguard through digital technology?
Well, again, this is not something that we directly do, but I think you can. I mean, I think the thing that you're doing, you have to anonymize, let's say, you can't allow this to be a shopping list for poachers, right? So you would have to have security on your networks. But, the global demand for wildlife goods, drugs, et cetera, those are huge social problems that we have to fix on one end. But the data that these guys can collect gives you the really interesting real-time patterns about where actions are taking place, so you can start to roll up these networks. It's not just the poachers on the ground, but it's the middleman who's trading it and who's moved into this other section and is now creating the incentive in this region, and so these data can be used by a team of folks to roll it up. It's one part of it. One thing on the stuff that I work on, we measure impacts of wildlife with the built environment. And so one of the unsatisfying things about it is I listen to things collide with things, right? And so that is sort of, on the one hand, it's really important because it's a rare event, we can hear it, we can actually start to explain how big a problem it is. But it's also kind of depressing because I'm just counting things colliding with things. And so there are groups, and one of the things that I think people can work on is how do you prevent something from colliding with that structure? And there's some real-time folks in Spain. There's a company called DT Bird that uses machine learning and video cameras to detect flocks of birds flying towards wind turbines, and then automatically detects that they're birds and initiates some sort of action. In this case, they play a sound, and the birds that are often looking down look up and turn away. So these sorts of things, there's some technology-driven, and I imagine there's some technology-driven
Matthew, let me ask Jake something about this. So how did you personally cope with losing that elephant? Did you cry? Were you sad? What happened? I mean, that must have been terribly anguished moments when you discover you've documented the death of a beloved elephant.
Yeah, absolutely. And I mean, this year has been a very bad year, as was last year. We've probably lost about 8 collared elephants that I know personally. I lost a good friend to poaching this year as well. Our hearts stopped.
You mean a person?
Sorry?
You lost a person?
A person, yeah.
A park ranger was killed as well?
He was a helicopter pilot, was shot down by poachers in Tanzania.
So how do you cope with such a difficult human reactions to this? How do you go forward?
I don't know. I mean, it's just, you have to have hope. You have to maintain hope that things will get better. And then I think there is building momentum. I think I think it's an education problem too. I mean, you mentioned that. Is it a tech problem? Well, no, not necessarily just a tech problem. It's an education problem. You know, most people I talk to don't realize that there's a crisis of ivory poaching in Africa. Oh, that's something we solved. You know, no, we haven't solved it at all, and it's come back. So.
Now yeah, go ahead, Ted. Sure, I'm sorry.
I think so. On the security thing, it's sort of like we do online banking, so we trust we trust our bank accounts online. I think we can trust that we can secure these systems in a way that only those that should see the data do see it. So that's one thing. And the other thing is, I think it does. We can do more than just sit and count. I think one of the things that we've learned we don't want to do is just sit and count as we walk over the cliff with climate change or with wildlife. We want to get out ahead of things. I think Jake's example with cooling is a great one. The fact that we had a collar, they were able to get a vet there before that they would have never, that the elephant would have died anonymously. They were able to get a vet there. Can we move that back? Can we catch the poachers? Can we even stop them from shooting the gun?
So some kind of real-time system, perhaps?
Yeah, and in fact, the last thing I
real-time
showed,
net?
the last thing that I showed in my presentation is really bringing all that real-time data together so that you have the managers of these parks that can deploy the helicopters, can deploy the rangers to get out in front of the problem. And so I think what technology provides is scale. It provides the ability to take the little bits of information we have, make them into big amounts of information, and then leverage that information, analyze it, and do real-time reaction.
Yeah, a very difficult problem. Other questions?
Matthew, it seems like your problem is a little bit unique from elephants are large, you can tag them, so you're sensing the environment. Do you have cameras? Do you have...
Exactly. We're sensing species, particular species that are hard to monitor. And so we actually will count the number of calls from a species, and those are related to actual densities of animals. You have to sort of prove that as you go out, but that's one thing we're doing. And cameras, you can start to identify individual animals is something that people are working on and we're working on. You can also look at kind of the soundscape in general. So if you're looking at sound sensors, what's the aggregate tell you about how healthy this forest is compared to this forest? All of the different things that make noise. And you can start to do that from above to looking at how healthy the habitat is and how the habitat is changing through time. And so all of these are classification problems in my head and in reality.
Yeah, final comment from Ted, and before we close.
Right. I just wanted to add that Vulcan Technology is looking for people that are passionate about these issues, that are technologists. We would love to talk to you. We are going to have a cocktail hour, 4 to 6 at Andina, that you're welcome to join. And we're really looking to build our team and find folks who are passionate about this issue and are also passionate about technology to help us solve some of these hard problems.
One last point. Let's have a moment of silence for culling in the passing of this animal, as elephant, and to support Jake and his community through this. This is very, very difficult. These great animals in sub-Saharan Africa have their own dignity and intelligence, and it seems we ought to do better. And at the beginning is to note their passing and what's happening. So thank you all. This is a wonderful panel. Just a beautiful job.